Hi, this is Chris Ashworth with FlexJet. Today we're going to talk about a subject that gets a lot of misinformation over the years, and that's look ahead and what look ahead actually means on the controller itself. We do have look ahead. Look ahead is on basically all the time, where in some controllers you can turn it on and off with G8, G9, G7. We don't do it that way. I just leave it active all the time. But now look ahead is only active on G1, 2, and 3 on your motion move or cutting moves. G0, you don't have that, the look ahead going on, or what we call positioning moves. They're just meant to get to a position as fast as possible. The look ahead will, it will not look through certain things. It will not look through M codes. It will not look through dwells like a G4 dwell. It'll actually cause the look ahead to interrupt or stop looking ahead during those segments. So if there was ever a need within a motion program to literally stop look ahead and let everything run out, you can do that by just putting a M0 or a G4 dwell command in there, and it'll do that for you. As far as what the look ahead is, it's made up of, there's four things that are involved in the look ahead, and that is the positive and negative limits of travel for each of the axes defined in the coordinate system. It's the maximum speed of each of the axes in the coordinate system, the maximum acceleration of each axis within the coordinate system. So with those four things in mind, plus and minus are considered two of those, you end up, if none of the axes exceed any of those limits, then the motion of the machine will maintain constant velocity through all the data points. And that's probably the simplest way to bring that part of it together. The other piece of the puzzle is, what does look ahead actually do to your part program? And it's actually taking your part program and time slicing it into very small time slices of every motion block within your program. And these time slices are defined by the company putting together the controller, whether it's 1 millisecond or microseconds or whatever, but it's breaking it up into that small of a time slice to give you the best trajectory, the best tool path that it can. Without exceeding the other four things that I mentioned, the plus and minus limits, the maximum speed, and maximum acceleration. Outside of that, it's going to maintain constant velocity. Now, I've set up a little demonstration of look ahead here on the screen, and that, from this standpoint, we actually show the operator the look ahead in action. And when I say that, you can see that we have a red line here that advances ahead of the active block in process. And that red line is showing you how far ahead in the program it's actually been calculated. This can actually advance much further than what we're looking at on the screen here. Like on some programs, we've been up to 10,000 blocks per second, and the look ahead will be right off the screen. It's looking that far in advance of what we're doing. Now, as far as what this particular example is doing, I have the program set for 1,500 inches a minute. Well, this particular program is very small moves. It's a small part. It never achieves 1,500 inches a minute. So what it does is the look ahead sees that it's going to exceed those limits, and it slows it down to maintain controlled velocity through all the data points. You'll be able to see a much better shot of the actual tip as this thing's running through the program. But overall, that gives you some idea of what active look ahead is. Again, I look forward to coming up with some more videos for you here at FlexJet.